So let's start now. Uh, I'll do a recap so that you're fresh in the morning, and we'll do a recap, quick recap. Yesterday we covered the define phase. In the define phase, we covered voice of the customer. We covered, 1 minute, just hold on. Sorry, there was a sound disturbance. I rectified it. Okay, so let's start with a quick recap. We did the define phase. In that, we learned the voice of the customer, how to capture the voice of the customer, and how to do the problem statement. What is the template for problem statement? Then what is the voice of the business? What is the voice of the employee? What are interviews? Face-to-face interviews. All these interviews are done using particular questionnaire. How do you go to each department? How do you go to each department like production, manufacturing, finance, payroll, and HR? Just hold on, there is some sound coming. Hello? Yeah, sorry. Some guests had come, so I told them to come later. So let's start now. We worked on the voice of the customer, voice of the employee, voice of the business. So what are the other things? Any other inputs from Hina? Hina, any other inputs?
No, sir, we started with the measure phase with the statistics and the mean mod median.
Yes. See, the thing is, the project charter is very important. The project charter is very important. Then comes the problem statement. Then comes the business case. The business cases, all the business objectives of the company are written down in the business case. What is the goal of the company? What does the company wants to achieve in another 4 years financially? That is all what is the main objective in the business case. Okay?
Yes,
so
sir.
let's start with the measure phase. Okay, let's start with the measure phase. In the measure phase, yesterday we learned what did we learn in the measure phase yesterday? Statistics. We learned statistics yesterday in the measure phase. No, yesterday in the measure phase we learned about statistics. What are the five main types of parameters in statistics? Mean, median, mode, and range, and standard deviation. Sometimes the mean, mode, and median is not able to get the variation. So the ultimate thing is to find out the standard deviation. The standard deviation is calculated using the formula sigma equal to square root of sum of x minus x bar the whole square divided by n, where n is the number of observations. We also knew how to calculate standard deviation using Minitab. We also know how to calculate standard deviation using Sigma XL. Okay, so this is the basic recap of what we did. Okay, now we come to the measure phase, module 2, slide number 3, not slide number 3, section 3. In that we have the measurement system analysis. Okay. By the end of this session, you will be able to define precision and accuracy, describe bias, linearity and stability, explain gauge repeatability and reproducibility, recognize variable and attribute MSA. MSA is nothing but measurement system analysis. As we go along, you will understand what is MSA. Okay, so by the end of the session, you will be able to understand define precision and accuracy, describe bias, linearity and stability, explain gauge repeatability and reproducibility, Recognized variable and attribute MSA. What is precision and accuracy? Accuracy is an unbiased true value and is normally reported as the difference between the average of a number of measurements and the true value. Checking a micrometer with a gauge block is an example of an accuracy check. What is precision? In gauge terminology, repeatability is often substituted for precision. Repeatability is the ability to repeat the same measurement by the same operator at or near the same time. See, this is what is very important. What happens is you measure the part or a piston with a measuring instrument. You have to understand that there is a standard for that piston, which is either given by the customer or the process owner. So, if the measurement is on par with the measure of the measure given by the process owner or the customer, it is called accurate. Okay. And what is precision? Precision is often substituted for precision repeatability to the ability to repeat the same measurement by the same operator at or near the same time. So if the same operator, there is some sound in the background. So in gauge terminology, what is a gauge? Gauge is nothing but a measuring instrument. A measuring instrument can be a vernier caliper. In physics, we have learned about vernier caliper. That is a system used to measure certain parts of the machinery, the vernier caliper. You see the diagram of the vernier caliper as we go along. See, the diagram shows that we have not met the target. The balls are outside the target. They are also accurate but not precise. But the now accurate and precise, the balls are inside the target, between accuracy and precision. See, the calibration of measuring instrument is necessary to maintain accuracy. What happens is you are collecting data, but if your measuring system is not accurate, the measurement which you feed into Minitab will not be correct. So that's why there should be an accuracy to be maintained by the measurement system. There should be an accuracy maintained by the measurement system. What is bias, linearity and stability? Bias is very important. Please note down the slide. Slide number 7, measure phase. Bias is the difference between the output of the measurement system and the true value. It is often referred as accuracy. Output of the measurement system and the true value. The true value is the measurement given by the standard, whatever standard is applicable, or whatever given by the process owner, or whatever given by the customer. And the measured value, the difference between the output of the measurement, that is the actual measurement which we do, and the value given by the customer. If there is a difference, that is called the bias. Bias is the difference. Linearity you not use much, bias is used much. Stability is very important. Variation in measurement when the same person measures the same unit using the same measurement gauge tool over an extended period of time. Gauge repeatability and reproducibility. What is repeatability? Variation in measurement when a person measures the same unit repeatedly with the same measuring gauge or tool. Measuring gauge is nothing but a tool which is used to measure a part which is manufactured in the industry. This measurement we are feeding into Minitab and finding out the variation in the process. That is what, so measurement systems are to be very accurate. That is what the meaning is. What is repeatability? Variation in measurement when a person measures the same unit repeatedly with the same measuring gauge. What is reproducibility? Variation in measurement when two or more persons measure the same unit using the same measuring gauge or tool. So here, repeatability, only one person is doing it. In reproducibility, there are more than two persons doing it. Okay, so this slide is very important. Gauge repeatability and reproducibility. Most important, slide number 9, measure phase.
So
Please note,
in both of them, you are getting the same results in repeatability and inclusivity. In both of them, you are
Yeah.
having the same results.
No, it depends on the scenario, what you are measuring.
No, now the question is, if in case one test is there, I am measuring the length of a rod. Now,
Okay.
in repeatability, only one person is continuously measuring the length of the rod 10 times, and in reproducibility, is two separate people measuring at the same rod and
Yes,
getting the
yes.
same result or different results?
That depends. They might get different results because there are two or more people involved. So one person can make an error. One person who is not much trained, he can make an error. How to use the measuring instrument. Okay. So the person has to be trained to use the measuring instrument. So there is an experiment now. I'll show you. There is an experiment for gauge repeatability and reproducibility, where the more than all the readings of the persons are taken into account, and thereby we find out what is the variation in their method of measuring. Okay, there is a method for that. Okay, rod or a piston, anything. See, one person can make a mistake. If there are more than two persons, we have to take the template for reproducibility, and we find that the variation is much less because one person can make some mistakes. If there are more than two persons, everybody cannot make a mistake. Yeah, this is very important. Slide number 10. Measurement system analysis, gauge repeatability and reproducibility. Acceptable level of measurement system data. Gauge RNR thumb rule, continuous data. What is the thumb rule? The thumb rule is acceptable RNR, gauge repeatability and reproducibility. That is called RNR. Percentage tolerant, RNR less than 8%. Acceptable. Okay, this is a thumb rule. This has been defined by the Six Sigma Council people. This is a universal rule. Okay. This is for continuous data. Continuous data is nothing but what? That data which can be measured, and discrete data is that data which cannot be measured by a measuring scale. So gauge RNR for continuous data is different, and for discrete data is different. Both are different. Okay. So this is how it is. Accuracy acceptable greater than 90%. Repeatability greater than 90%, reproducibility greater than 90% is acceptable. I'll show you a template where it will be clear to you what is how to do the gauge repeatability. Okay.
Sir, in the previous slide, the gauge RNR and the second one for the discrete data, it was mentioned as attribute RNR. So is it like some different methods in which it is being measured, or that is how it is named?
See here, when we go to the MSA in the Sigma Excel software, you will understand it much better. This slide will not explain to you much in a better way. Sigma Excel software is there, right? I'll show you there how it is gauge RNR is done. Gauge RNR is done. So it will be much clearer to you.
Okay.
One minute, I'll just put on the fan now. So, if sound is coming, just tell me. Any sound coming? Okay. Now we'll go to, we have variable and attribute MSA. This slide is just a summary. Observed process variation, variation from measurement system, actual process variation, variation from appraiser, variation from gauge. It can be variation from the appraiser also. The appraiser will be also making some mistake. That is the person who is measuring it. Variation from gauge, there might be mistake from the instrument also. Accuracy, stability, reproducibility, repeatability and linearity. Variation from controllable factors and variation from uncontrollable factors. Variation can be either from controllable factors or from uncontrollable factors. These are the various variations where you find in variable and attribute MSA.
Sir, can you take 2 minutes more on the previous slide, sir? Can you give us a few examples?
Variation of measurement system. Yeah, variation from measurement system. No. See, what happens is that while measuring piston, I have taken a sample of 10 pistons from a population of 100 pistons, and I'm using a measurement measuring gauge to measure the diameter of the piston. And I find that the measuring instrument is giving me some values which I noted down. Further, later when I check with my process owner or with the company head or the department head, I find that the measurement system, that is the system which I was using to measure the diameter of the rod, was not up to the mark. So we have to find a good measuring system. Okay, that is what variation from measuring system. If there is a variation in if the measuring system is not up to the mark, there will be variation in it. Variation from appraiser. Appraiser is a person who is an operator in the factory who is measuring the rod or the piston. He can also do mistakes, and that mistake should be entered in Minitab. Variation from gauge. Variation from gauge, then what I told earlier. That is measuring system. So variation from measurement system can be from variation from appraiser and variation from gauge. Actual process variation is what? Variation from controllable factors, variation from uncontrollable. Uncontrollable factors can be, say for example, your one pizza delivery guy is delivering a pizza to a person. The lead time is 30 minutes. But due to some accident, it takes 2 hours. That is variation from uncontrollable factors. These are not controllable. That's not in our hands. We cannot do anything. If accident happen, it will happen. Those are variations. The lead time is increased to it by 2 hours. So there is a lot of variation in the process. These are variation from uncontrollable factors. Okay. Is that fine?
Okay, sir.
Process capability. This is very important. Process capability. Okay, what is process capability? By the end of the session, you will be able to perform capability analysis, explain the concept of capability, define attribute and discrete capability, illustrate the different monitoring techniques. Okay. Capability analysis. Yesterday we saw a graph, okay, where the upper specification limit and the lower specification limit that is given by the customer. If the data is above the upper specification limit and lower specification limit, it is called as a variation in the process. A capable process is a process whose spread on the bell-shaped curve is narrower than the tolerance or specification limit. USL is the upper specification limit and NSL is the lower specification limit. Okay. What does this process capability study include? Planning for data collection, collecting data, plotting and analyzing the results. That we can do using Minitab. Actually, slide number 5 is not very much important. So you don't have to go to that. Identifying characteristics, capability analysis. We are still doing on capability analysis and process capability. There are some formulas which I'll share with you how to find the process capability. Okay, that with those formulas we can do the capability analysis or find out the process capability, whether the process is capable or not. The identification of characteristics to be measured in a process capability study should meet the following requirements. The characteristic should be indicative of a key factor in the quality of the product or process. It should be possible to adjust the value of the characteristic. The operating conditions that affect the measured characteristics should be defined and controlled. Okay. So characteristics is nothing but the process. This is important. Slide number 7. The process specifications or tolerances are determined either by customer requirements, industry standards, or the organization's engineering department. So all this tolerance limit, upper specification limit, lower specification limit are determined by the customer requirements, industry standards, what are the industrial standards, or the organization's engineering department. The process capability study is used to demonstrate that the process is entered within the specification limits and that the process variation predicts the process is capable of producing parts with the tolerance requirement. So the tolerance limit, it should not go above the tolerance limit. If it goes above the tolerance limit, the process is not capable. So it is an incapable process. When the process capability study indicates that the process is not capable, the information is used to evaluate and improve the process in order to meet the tolerance requirements. So we have to redo the define, we have to go back to the voice of customer. If we find in the measure phase that the process is not capable, there are variations in the process, we have to go back to the voice of the customer, again start from scratch. Okay, so that is the main meaning of this. We have to again start from scratch. Concept of stability. Process stability. Common causes or a variation can be done either caused by either what? Common causes. Day-to-day operations can cause variations. Special causes. As I told you, the pizza boy is going to deliver the pizza to a customer, but he suddenly meets with an accident and the pizza delivery gets late. It's a special causes of variation. Attribute and discrete capability. These are charts which you have to go through the graph of Minitab or Sigma Excel, and they will show you the attribute and discrete, whether the process is in control. Yesterday I showed you one graph where the process is going above the lower specification limit and above the upper specification limit. So there are variations in that process. So what we have to do if there are variations, we have to go back again to the process owner or to the voice of the customer and again start the whole process. This slide is not that very much important. I'll show you some instruments which are used in the factories. See here, these are instruments which are used. There is an instrument shown here. Then I'll show you one more instrument. These are spring calipers, dial calipers, vernier calipers, digital calipers. All these are instruments. See here, these instruments are shown in the screen. These are all measurement system instruments which are used in factories. These are spring calipers to measure the size. See here the vernier caliper. We are used it in physics, what you call during your 12th standard or during your degree studies or all. Vernier caliper. This is a vernier caliper. This is a measurement system. It's a measurement system. See, this is a digital vernier caliper. Okay, this is a digital vernier caliper. It shows the image, the measurement in a digital format. This is much more accurate than the older vernier caliper because here the measurement system gives it much in a much more accurate way. This is a micrometer. Then there are ring gauges, plug gauges. All these are used in factories. You can go through this. This is a very self-explanatory. You can go through this slide and you can understand this. Only some questions will be asked in the examination from the slides. Okay. Imagine this, all these machines will not be asked in the examination. Interferometry, all these are not, will be not at all asked. And whatever is the main required, I'll show it in the template. Okay. So these are all not much required. Non-destructive testing, these are all not asked in the examination.
Sir, I have one question.
Hmm.
Sir, these are the measuring tools for manufacturing companies, right?
Yeah.
When we go for a manufacturing companies. But when we are doing something process change in a service industry, like I am basically from the service industry.
Yeah.
My process change is basically with the process. There is no actually physical things are there.
Yes.
So
Your
how
thing,
we,
you have asked a very intelligent question. Your case will be, you are working in a service industry. So there is
correct.
no rod or there is no piston or there is no other shirt or pant to be measured. Okay.
Absolutely.
So your case is you have to do the process. I'll tell you which all process you will have to do. Which all phases. Define. You have to use the define phase. Okay. Then the measure phase you collect data. And in measurement system analysis you don't have to do anything. You have to only collect the data because you're not going to use any gauge or any instrument to measure the data because there is no physical anything. You have to just keep it. What will be useful for you will be failure mode and effect analysis, fishbone diagram, Ishikawa diagram, and in the analysis phase, you will have to use a hypothesis testing. You have to just skip this. Very simple it is. What you don't use it, you don't have to break your head on learning it. Okay.
And one more thing, sir. I'm personally from HR department. So we are when we used to do the process analysis for any of the processes in the HR, like we initially implemented the work from home policies, especially for the women's.
Yeah.
We actually had for the IT technicals, but we started for other departments also, like finance. Those are supporting functions. So we are basically not with the related with the customers or anything like what you will say in terms of money, but basically in terms of capability, so that we can increase the capability.
Customers are internal customers. We discussed earlier, no? The customers are internal customers.
Yes.
You don't have external customers. You have internal customers. So there are customers. What you said, you don't have customers. There is customer for you. Everybody has a customer. Everybody has a customer. internal or external, whatever it may be.
Hmm.
Yeah, tell me. You continue. I'll give you how to. I'll give you a plan how to tackle your problem. Tell me. Continue.
Actually, sir, sometimes we don't have to check about the, how much we save in terms of money, but how much we can increase the capability.
Yeah. So you have to do first taking all these things. You have to first put it on a what is the problem statement. You have to define the problem statement. You have to
Mm-hmm.
take the voice of the employee, hmm, not voice
Mm-hmm.
of the supplier or external customer. Take
Yeah.
the voice of the employee. Put it on a Ishikawa diagram. And
Mm.
all this put together, what is you have to define the problem statement first. What is the problem statement? What are the employees facing? What problems the employees are facing? Hmm?
Mm.
All these
Yeah.
problems you have to put it on a Ishikawa diagram. And your department is HR. And
Yeah.
once you have to brainstorm the problem. Brainstorm
Yeah.
the problem with your manager or with your superior. And then what you do is put it on a FMEA, that is failure mode and effect analysis template. Hmm? And then calculate the risk priority number before action and after action. Before action, you have to take a particular action. If the employee requires training, what is your current problem now in your organization? In the HR department?
Actually, sir, we have some issues related to the system. Sometimes our system crash in a very critical, like right now we have income tax calculation was there and the system was crashed for entire 48 hours. So there was a lot of chaos regarding the same. So we started with the process improvement so that how we can smooth the process, especially in the terms of income tax return and the income tax filing,
No,
especially
but
for
you are
the
using a software to calculate the income tax. No?
yes, we do have, but system we can't rely 100%.
You
Sometimes it
say,
crashed.
no, you have to rely on system because this is the age of software. If you don't rely on software, then what will happen here? Banks, banks are using software only. If there's nothing crashes in banks, how come it is crashing in your Amazon only?
Sir, I'm from Tata Communications.
Tata
It's a
Communication.
it's a SAP, it's a success factor, and there was some issue, but suddenly it crashed. Although they have given us the backup, but for 48 hours the system was blocked.
Who has developed it? This has developed in-house or this has been developed by an external company?
So it's a SAP. It's a world-renowned company.
SAP is a world renowned, but then there is a problem with your system administration. SAP will never cheat you. I know SAP. SAP is a very big ERP and they are known
But
worldwide.
they won't cheat us. They won't cheat us, but there was bugs, and we are trying to fix step up, but it won't help. It was crashed for 48 hours, and then they said we'll give you they gave us the backup, but still for 48 hours the system was slow, or you can say crashed. We are not
That you
able
have
to see
to,
anything.
that is the part whether you have to solve the problem with the superiors and get the bug certified and do a kind of a role where things have to be delivered on time by the supplier because SAP is your SAP. You are the customer for SAP, so you can demand. You are now the change the situation. You can demand. I am the customer. You give me this on time, otherwise I will not make the payment. Okay, your this role has been reversed. Your case is that you have become a customer now, and SAP is the company which is supplying you the service.
Yes.
So here you don't have to do any Six Sigma kind of thing. It's a very simple, straightforward problem. You have to catch hold of the vendor and tell him that you get this writing there, otherwise I block the payment.
Yeah.
Okay, here you don't do, you have not, see that's what I told you, you have to select your Six Sigma projects. Don't blindly say that everything is Six Sigma project, yeah. Everything cannot be Six Sigma. Now here you don't know who the customer is and who the supplier is. And you are telling how you can implement Six Sigma there. It's not possible to implement Six Sigma in this. So you have to bifurcate where you have to use Six Sigma and where you are not to use Sigma. In your case, you are the customer. How can you implement Six Sigma? Yeah. Okay, then fine. So now you are working in the HR and service industry. So your case will be that you have to just collect the data in the measure phase, and you don't have to bother about the measurement systems like digital calipers, vernier calipers, and anything, because they are used by the manufacturing industry. So the manufacturing industry focuses on all this. Magnetic particle testing is used by the manufacturing industry, especially the steel industry. Nobody is from steel industry, so I need not tell you about that, and it's not valid from the examination point of view also. These are the slides which are not valid. That's why I'm skipping those slides. Not valid from the examination point of view. Whatever is valid from the examination point of view and whatever adds experience to your profile, I'm taking it. The rest I'm skipping it because it will unnecessarily confuse you and consume your time, my time. These are all radiograph and all used by hospitals and X-rays. These are used by basically. Now this is tensile test, shear test. Tensile test is to measure the tensile strength of a metal. Okay, these are various tests used in the manufacturing company, especially steel companies. Now, we have finished the slide for measurement system analysis. Now, I'll give you a formula how to calculate process capability. How to calculate that, I'll give you a formula. So, in Hina's case, you will not be using any of the digital calipers or any of those because that's not required. What you have to do is directly go into define phase, then collect data from the measure phase, skip measurement system analysis, go to analyze phase, and then improve phase, and then control the project. That's all. I hope I have given you this document which I'm sharing with you. This document is very important. Yeah. See here. So we can go to this. What is the thing? The process capability is calculated using the formula Cp is equal to upper specification limit minus lower specification limit divided by 6 into standard deviation. Okay. So upper specification limit is given by the customer, lower specification limit is given by the customer, and the standard deviation you have to calculate. So how to calculate it? Cp is equal to, note down this formula, upper specification limit minus lower specification limit divided by 6 into standard deviation, where Cp is equal to process capability index, USL is equal to upper specification limit, and LSL is equal to lower specification. The process capability measures indicate the following: process is fully capable, process could fail at any time, process is not capable. Okay, so this formula you have to learn it by heart. It's a very simple formula and can be used to find out the process capability. Okay, any doubts till here? Everybody, any doubts till here how to calculate the process capability?
Sir, why do we calculate process capability?
Oh, because you have to find out whether there is a variation, no? Where there is a variation, if there are variations in the process is not capable. So there is no point in doing the project. If there are variations in the process, then the whole manufacturing, whatever the parts they are manufacturing in the company, is totally wrong, and it goes to the customer and the customer starts complaining. You will lose business, you will end up financial losses, and you will go bankrupt. Okay, now you are clear? Hello?
Yes, sir.
Yeah, you will go bankrupt if there are variations in your process. Then it will affect your money, your return of investment. Everything will be affected. That's what I was telling you. I think I told you in the earlier classes also, return of investment, ROA, ROI, all these are important. If your money, see, the main thing is money. If your company is not making money, what is the point? If there are variations, your company will not make money because there will be no customer only for you. The customer will throw you out. Is this thing everybody clear to everybody? Upper specification limit minus lower specification limit. This is given by the customer. Okay, or the process owner, that is the head of the department, head of the production department or head of the manufacturing department or head of the HR department, whoever it may be. Is it clear, Hina?
Yes, sir.
Yeah, okay. We'll take a break for 10 minutes and you can, this Word document I have shared with you. I hope I have shared it with everybody, no? Hina, have you got this Word document?
Sir, I'll have to check.
Yeah, I'll send it at your email ID. You have a check at it because it is named as this. You check it out. It is called DMAIC framework, hypothesis testing DMAIC framework. Check it out right now and tell me if you are not received it because it's a very important document which I have to give you. Okay. So CP is equal to upper specification limit minus lower specification limit divided by 6 into standard deviation. Standard deviation is a calculated formula. Yesterday I showed you that formula how to calculate standard deviation. You can calculate standard deviation and put it there and do it in the software, or either you can do it manually or do it in the software. Either way. Okay, we'll take a tea break for 10 minutes. Is that okay?
Yes, sir.
Okay. Yeah, Hina.
Yes, sir.
Yeah, now from the examination point of view, I cover one more topic, that is DFSS. What is DFSS? DFSS is called Design for Six Sigma. This is basically a form of used in the defined phase itself. Okay. From the diagram, it is very self-explanatory. While DMAIC may be traditionally viewed as a foundation for Lean Sigma, DMAIC that we have discussed, define, measure, analyze, improve, and control, viewed as a foundation. So its application is primarily limited to improving existing process. DMAIC does little to address the design of new products or processes. You understand the difference between DFSS and DMAIC? DFSS is called Design for Six Sigma. Please note it down. From the examination point of view, they will ask you what is DFSS. DFSS is called Design for Six Sigma. DMAIC is viewed as a foundation for Lean Sigma. Its application is primarily limited to improving existing processes. Okay? But DMAIC does little to address the design of new products or processes. Okay? So what we do? We use DFSS for improving new products or processes. So DFSS is nothing but for new products. If you want to address the design of new product or processes, what we use there? We use DFSS. We will not use DMAIC. What are the main parameters of DFSS? The main parameters of DFSS as shown in the diagram. See here, the diagram is given. DFSS, DMADV, DMADOV, DMEDI, and ITOV. These are the main parameters of DFSS. Till now, everything is clear. What is DFSS? You are clear about, Hina?
Yes, sir.
From the examination point of view, DFSS is very important. You should know what is DFSS. DFSS comprises of what? DMADV, DMADOV, DMEDI, and ITOV. So DFSS is made up of DMADV, DMADOV, DME, DI, and IDOV. Okay. So table 1.1 has been created as a loose comparison between DMIC and DMAD. Okay, what is DMIC? DMIC is define, measure, analyze, improve, and control. What is DMADV? See, DFSS is given here. I showed you, and DFSS contains all these things. DMADV, uh, DMEDI, IDOV. All these are contained in DFSS. And what is DMADV? DMADV is define, measure, analyze, design, verify. Okay, so there is a slight difference. Okay, and what is DMADOV? Define, measure, analyze, design, optimize, and verify. Okay, and what is DMEDI? Define, measure, explore, develop, and implement. And what is IDOV? Identify, design, optimize, and validate. This I have taken it from the Master Black Belt book. This will be asked in the examination. Okay, what is DFSS? If you are appearing for the IASSC or the ASK. So, and from the examination point of view, I am giving you this. The difference between while DMAIC may be traditionally viewed as a foundation for Lean Sigma, its application is primarily limited to improving existing process. So DMAIC is for existing processes. It does little to address the design of new products. So when it comes to design of new products or processes, we use DFSS. Okay, not DMAIC. We have to use DFSS. And DFSS contains of DMADV, DMADOV, DMEDI, and IDOV. This document I have shared with you. Please check your emails and you can have a look at it. What is design? See, here it's given here. You have to just remember this. This means carrying out the process of designing a product or process. Many organizations have well-established policies and procedures for their respective design processes. One valuable Lean Six Sigma process that supports the design process is quality function deployment. Okay. QFD. QFD is a template which I'll share with you. Okay, it's available. So this is all what is all DFS is all about. DFS is important from the examination point of view. DFS is slightly different from DMAIC and it is called Design for Six Sigma. This is used when you design a new product or a new process. It is not for improving the existing process. For improving the existing process, we use DMAIC. Define, measure, analyze, improve, and control. Okay. Now, any doubts till now? Here I have mentioned, given all this very simple way, tools of the trade, tools used in define phase. This I'll share with you. I already shared with you tools in measure phase. What are the tools used in measure phase? What are the tools used in analyze phase? What are the tools used in improve phase? And what are the tools used in control phase? Okay, now getting back to the measure phase. We have to ask this following question. What needs to be measured? How to measure it? What is the customer requirement? See, I have highlighted this. What is the customer requirement? What is the variation between the customer requirement and the current level of performance? Is there any additional measurement required to precisely know the problem? What measurements are required of the processes improved? Okay. What needs to be measured? How to measure it? What is the customer requirement? What is the variation between the customer requirement and the current level of performance? Is there any additional measurement required to precisely know the problem? And what measurements are required after the process is improved? These are the various questions you ask in the measure phase. We had discussed about this gauge, repeatability and reproducibility R&R study. Repeatability also known as equipment variation and reproducibility also known as appraiser variation. See, very simply it is given there. What is repeatability? Repeatability is the equipment which is used that is causing the variation. And reproducibility is the operator who is using that equipment. He is causing the variation because he is not properly trained. So repeatability also known as equipment variation and reproducibility also known as appraiser variation. Please note this down. Repeatability, gauge repeatability and reproducibility R&R study. Attribute R&R study is for conducting study on discrete variable and not continuous variable, which can be measured on a measuring scale. Okay, continuous variables are those variables which can be measured on a measuring scale. So there is a council for this, the MSA, manual published by Automotive Industry Action Group. This is a committee, Automotive Industry Action Group, specifies the following norms. If GRR is less than 10%, the measurement system is acceptable. This is a thumb of the rule, rule of the thumb. If GRR is less than 10%, measurement system is acceptable. If GRR is between 10 and 30%, equipment may be accepted based upon the importance of application, cost of measurement, device cost of repair, etc. Measurement system is not acceptable for GRR beyond 30%. Okay, so measurement system is not acceptable for GRR beyond 30%. I'll show you one example. Click on this. This templates I've shared with you. Okay, measurement system analysis, Excel sheet. This is an Excel sheet. Here, see, this is a template here, which in the yellow, you see the yellow part. Everybody is listening to me, I hope. Where the customer gives the upper specification limit. I can say as upper specification limit as 70 and lower specification limit as 20. And see, this is a macro enabled. As everybody aware of what is a macro in Excel? Ina, you are aware?
Yes, sir.
Yeah. See, now in this Excel sheet, it's very simple. You have to just enter the reading 1. Reading 1, 12, not 12, sorry. Between 20 and 70 you have to enter. 25, you enter 25, you enter 23 for part 2. That is the second part. But this is done by operator A and operator B. So this is a reproducibility MSA, not repeatable MSA. Okay. Now here you enter 27. So like that you go on adding it, you get the answer here. You get the answer here. Less than 10% acceptable percentage GRR. I discussed with you in this document, no? Percentage GRR. If GRR is less than 10%, the measurement system is acceptable. So you have to fill in this. Kindly fill in this. Now, fill in this in the only in the yellow part. Have you received this template? Can you check in your folder, please? Hina, can you check in your folder?
Yes, checking, sir.
It will be written as MSA or measurement system analysis. This is a macro enabled spreadsheet where you have to just enter the input values. The result will be automatically calculated by the macros. They will do the calculation. See, everything is getting calculated as you go ahead. 23, 24, 25, part 4, 56, 57, 58, part 5. Like that you have to go for each operator and you will get the result here below. Here you will get the result. Percentage GRR. In the yellow box, no, you will get the result. Okay. These are very complicated formulas which a green belt or black belt need not remember. It is then automatically calculated by the macro. Okay. So it's not, it's very difficult to remember these formulas for a gauge reproducibility test. Okay. This is humanly impossible to remember all those formulas. So that's the reason we use macros. Okay. If you have not received this Excel sheet, please tell me. I'll forward it to you. Has Sumant received this Excel sheet? MSA macro enabled Excel sheet? See here I have highlighted this part. Can you check it? What I have written? It is very important to know that if the process is found to be stable using capability analysis formula and by gauge R&R study, we can directly move to the control phase. We can skip the improve phase. Else we have to start again from define phase. See, the process is not found to be capable here by means of gauge R&R study or by means of using the formula process capability is equal to upper specification limit minus lower specification limit divided by 6 into standard deviation. If the process is not capable, what you can make that you have to go back to the define phase once again. You have to go back to the voice of the customer. You have to go back to the problem statement. You have to go back to the business case. You have to go back to the scope of the project. You have to find out the quality, critical to quality. You have to calculate the financials. You have to calculate the financials because financials is important. Otherwise, your company will go bankrupt. Okay, fine. All of you are sitting for the black belt course also. All of you kindly tell me.
Yes, sir.
Yes, sir.
Okay, so this is Poisson distribution and exponential distribution which I have highlighted here. See here. All these things will be covered when we take the black belt course. Okay, so that you need not remember now. That is out of the scope of the green belt. So that will come under black belt. Okay, so this is a current scenario. Okay, fine. Now we move on with the slides. We finished this process capability, so we did not take it back. So we have finished with the measure phase. Now we move on to the analyze phase. This is the third part, define, measure, analyze. This is the third part of the DMAIC, where DMAIC is used to improve the existing process and DFSS is used to for a new product, for designing a new product or a new process. So there is a difference between DMAIC and DFSS. And DFSS contains DMADV, DMADOV, IDEI and IDOV. Okay. So there is a difference which will be asked in the exam. What is the difference between DFSS and DMAIC? Okay. So you have to note it down. Analyze phase. By the end of this phase, you will be able to explain the different parts of patterns of variation, describe inferential statistics, illustrate hypothesis testing, perform the different hypothesis tests for normal data, perform the different hypothesis tests for non-normal data. Pattern of variation. What is multivariate charts? Multivariate charts are used to investigate the stability or consistency of a process in the analyzed phase. They are just in the form of a graph. Multivariate charts are just in the form of a graph. Okay. What is a multivariate sampling plan design process shown in the form of a flowchart? Select the process and the characteristic to be investigated. Select the sample size and time frequency. Set up a tabulation sheet to record the time and values from each sample set. Analyze the chart for variation both within the sample set, from sample to sample and over time. Join the observed values with appropriate lines. Plot the multivariate chart on graph paper. So you have to draw a graph. It's very simple, nothing complicated about it. You have to select the sample size, select the sample and then draw a graph. And from the graph you infer whether there is a variation in the process or there is a consistency or stability in the process. Multivariate analysis is concerned with two or more dependent variables y1, y2 being simultaneously considered for multiple independent variables x1 and x2. We have discussed this function y is equal to f of x in the defined phase. Okay, so where y is the dependent variable and x1 is the independent variable. So the first one for multivariate concept is, from the examination point of view, you have to note this down: multivariate analysis. That is discriminant function analysis. In multivariate tools, discriminant function analysis is one of the multivariate tools.
So Hina here had a question. So for this multivariate analysis, does that mean that there are two dependent variables y1, y2 which are simultaneously getting affected by independent variables x1, x2?
See here it is given, no? See here, multivariate is concerned with two or more dependent variables y1 and y2. It's very simple, it's very written in a fairly very straightforward way. It's simultaneously considered for multiple independent variables x1 and x2. So more than two dependent variables are coming into the picture for multivariate. That is why it is called multi. Okay. Multiple. That is why it is called multi. This is very important. What are the classes of distribution? Please make a note of this. What are the different classes of distribution? Multivariate analysis, no, you can find the option in Minitab. Okay, in Minitab there is an option called multivariate analysis, and you can draw a graph using that multivariate analysis. So commonly used distributions include normal, binomial, Poisson, chi-square, students P and F distribution. Most important, it will be asked in the exam. So commonly used distributions include normal, binomial, Poisson and chi-square. Students P, that is not student, it's now called P, and F distribution. So these are the distributions which are commonly used. Distributions are nothing but which are terminologies used in statistics. Okay, commonly used distributions include normal, binomial, Poisson, chi-square, students P and F distribution. Normal distribution. What is normal distribution? Has numerous applications. Useful when it is equally likely that readings will fall above or below the average. When a sample of several random measurements is averaged, distributions of such repeated sample averages tend to be normally distributed, regardless of the distribution of the measurements being averaged. This is called a normal distribution. It will fall above or below the average. That is called a normal distribution. And what is binomial? Binomial is used to model discrete data, applies when population is large. If you are using a large population, if you are taking samples from a large population, so you are applying binomial distribution when number of observations greater than 50. Best applied when sample size less than 10% of n. Don't look at approximate to hypergeometric distribution. Hypergeometric distribution is not used nowadays. Poisson distribution. What is Poisson distribution? Used to model discrete data. Used to model rates such as rabbits per acre, defects per unit, or arrivals per hour. Yes, discrete data is what? Which cannot be measured. Okay. So Poisson distribution is used here. Poisson distribution. You can see in Minitab, there is Poisson distribution, there is binomial distribution option is there. You can use the data there and find out the models are rabbits per acre, defects per unit on arrivals per hour. Use as a distribution for defect counts. How many count of defects are there? What is chi-square distribution? This is important from the examination point of view. Used to make decisions and constructs confidence intervals. Okay. This is also a sampling distribution. Sampling has various distributions in statistics. That is normal, binomial, Poisson, and chi-square. So this is a statistical term in population of sampling or in sampling. Students distribution is not used anymore. I'll show you a sample of normal, binomial and Poisson distribution with an example. So you'll be able to understand it. Now we are into analyze phase, inferential statistics. By the end of the session, you will be able to interpret inferences, identify the sampling techniques and their uses, discuss the central limit theorem. Okay. So what we have learned in statistics is We have learned in statistics that is mean, mode, median, range, standard deviation, normal distribution, binomial distribution, exponential distribution, and Poisson distribution and chi-square distribution. These are all statistical terms. Okay, all are statistical terms. They are coming under the part of statistics. See here, I told you, right? Inferential statistics is a set of methods used to draw conclusions or inferences about characteristics of population based on data from a sample. See here, it's very simple from this diagram. Here is the population, right? And the subset is a sample. And what we do, we cannot measure the entire population. Yeah, in a company of Toyota and all, or in a company like Gabriel India, where they make shock absorbers. It goes in tons, and the number of production goes in tons. So we cannot measure the entire population. What we do is take a subset of the population and then draw a inference about that population. You cannot take the entire population. It's humanly impossible to take the entire population and do it. So from the diagram, it is very clear. Very important slide. Slide number 6. Analyze phase. Module 3. Slide number 6. Analyze phase. The objective of statistical inference is to draw conclusions about population characteristics based on the information contained in a sample. The steps involved in statistical inference are define the problem objective precisely, decide if the problem will be evaluated by one-tailed or two-tailed test, formulate a null hypothesis and an alternate hypothesis. This I'll explain to you what is a null hypothesis and an alternate hypothesis. Select a test distribution and critical value of the test. Calculate a test statistic value from the sample information. Make an inference about the population by comparing the calculated value to the critical value. Communicate the finding to the management. I'll discuss with you what is hypothesis test. Hypothesis test are used in analyze phase. They are used to draw a inference about the population. We take a sample from the population and that sample has to go through various tests like hypothesis test, t-test, two-tailed test, and when these tests have been done and confirmed, we can know that there are variations in the measurements in the sample or the samples are defective or not. If the samples are found to be defective, the company will go for losses. The customer will start complaining and you have to again go back to the voice of the customer. Sampling techniques and uses. What are the sampling techniques? Sampling is the process of selecting a small number of elements from larger defined target group of elements. This is very simple, very straightforward. Sampling is done in situation when the process involves destructive testing. That you forget, that is very slightly confusing. Then there are constraints of time and cost. When the populations cannot be easily captured. This is very important. In a company like Toyota, you cannot capture the entire population. Sampling is not done in situations when the events and products are unique and cannot be replicable. That means some products which are very unique and cannot be duplicated, their sampling cannot be done. Something happened, I crashed the Acrobat. What are the sampling techniques? Probability, no probability. There are two types of sampling techniques, probability and no probability. Probability is simple random sampling, stratified random sampling, systematic sampling, and cluster sampling. This should be asked in the examination. What are the sampling techniques? Probability and no probability. In probability, what are they? Simple random sampling, stratified random sampling, systematic sampling, and cluster sampling. I hope this is clear to you. What is simple random sampling? I'll explain to you in the next slide. Stratified random static, systematic sampling, and cluster sampling. Sampling techniques are of two types, probability and no probability. What is simple random sampling? Simple random sampling, it is a method of sampling in which every unit has equal chance of being selected. So you pick up something randomly. That is what simple random sampling. What is stratified random sampling? It is a method of sampling in which random groups are created and then units are picked randomly. Okay, so small groups are created. This diagram is very self-explanatory. Anybody having doubt in this diagram? Nina?
No, sir.
A very self-explanatory diagram. This is a simple random. Stratified random sampling, you create groups and from the groups you pick up. That is stratified random sampling. What is systematic sampling? Systematic sampling is a method of sampling in which every nth unit is selected from the population in a given period of time. Okay, so this is the diagram is fairly self-explanatory. And what is cluster sampling? Cluster sampling is a method of sampling in which clusters are sampled every period time. A specific time is there. These are all very self-explanatory. And what is given here in bold, no, is the same what I'm reading out there. Okay, there is nothing that which has been left out. And I'm giving you only important points to note it down. If you are not noted down, it's your problem. You might find it difficult to pass the exam. Most important, slide number 20, analyze phase, central limit theorem. This should be asked in the exam. Central limit theorem. You have heard about theorem in mathematics, no? Somewhat like same thing. This is a theorem. Everybody, I think, have done the engineering. Some have done Ayurvedam, but some have done engineering. They must have come to know about theorem and all. Okay. So please note that what does this theorem say? If a random variable x has mean mu, mu is the word here, mu, the finite variance sigma square, as n increases, x approaches a normal distribution with the mu and variance sigma x square, where sigma x square is equal to finite variance divided by n, and n is the number of observations on which mean is based. What is the meaning of this, Hina? Can you tell me?
No, sir, I'm trying to gather what does that mean.
Yeah, see, it's very simple. It states that as the number of sampling, as the number of observations are more, then the graph shows a very normal distribution. Okay, as n increases, that is n is the number of observations, x approaches a normal distribution. That is, it shows the bell-shaped curve, which is shown in the graph there. It shows in the form of a very good bell-shaped curve. The bell-shaped curve shows that the distribution is normal. If the distribution is not normal, the bell-shaped curve will go in a skewed manner. It will move away from the axis, that vertical line is shown there. No? It will move away from there. So this is the central limit theorem. The central limit theorem states that as the number of observations increases, the variable x, the random variable x, approaches a normal distribution. Okay? This much you remember. As the number of observation increases, the random variable x approaches a normal distribution. This is central limit theorem. Very simple, straightforward. Nothing much in this. This will be asked 100%, 100%, not 200% you take. Central limit theorem. So we had discussed in the analyze phase something about hypothesis testing, right? Unfortunately, in this slide, there are not much given on hypothesis testing, but I'll explain to you from this Word document which I have prepared. Here, note this, very important. You are able to see this, no? Everybody?
Yes, sir.
Parametric hypothesis testing. This is not given in the slide. Okay? You have to note this. I'll read out to you. A hypothesis is a value judgment made about a circumstance, a statement made about a population based on experience. An engineer can, for instance, assume that the amount of carbon monoxide emitted by a certain engine is twice the maximum allowed legally. However, these assertions can only be ascertained by conducting a test to compare the carbon monoxide generated by the engine within the legal requirements. See, nothing, very simple this is. Say Hina says, I went to a movie called Ram Lakhan. It was a good movie. That is the null hypothesis. It was a good movie. But I give an alternate hypothesis. It is not a good movie. So it is equal to and not equal to. Equal to a good movie. Not equal, it's not a good movie. This is what, there are two types of things. Null hypothesis and alternative hypothesis. What is the meaning of hypothesis in English term? Meena?
It's a proposition.
It's a proposition. Assumption.
Okay.
You are not proposing anything here, yeah. You are assuming things. But whether your assumptions are correct or not, you have to do some test to prove that, right? Okay. And those tests are given below. Okay. You have to do some tests to prove that. And the formulas which you are going to use, no, that will be discussed in the black belt session because you have taken a combo pack. So this is out of the scope of the green belt. So what are the formulas? I'll tell you. I'll just give you a fair amount of idea the formulas used. Say for example, now for hypothesis testing you require data, right? Everything requires data. Without data you cannot do any testing. Testing cannot be done without data. If the data used to make the comparison are parametric data, that is data that can be used to derive the mean and the standard deviation. That is a continuous. It can be measured. If the data used to make the comparison of parametric data, that is data that can be used to derive the mean and the standard deviation, the population from which the data are taken are normally distributed, they have equal variance. A standard error-based hypothesis testing use the t-test can be used to test the validity of the hypothesis made about the population. There are at least 5 steps to follow when conducting hypothesis. See, I made a hypothesis about a population. There is a population of 100 pistons. I've taken 10 pistons from that and I made a hypothesis. I assume that the parts are defective. But I give an alternate hypothesis that the parts are not defective also. So there are 2 assumptions, either equal to or not equal to. And what is a population? It is a term in statistics. What is the first step in doing the testing? Null hypothesis. The first step consists of stating the null hypothesis, which is the hypothesis being tested. In the case of the engineer making a statement about the level of carbon monoxide generated by the engine, the null hypothesis denoted by HO. The null hypothesis is denoted by HO. The level of carbon monoxide generated by the engine is twice as great as the legally required amount. The null hypothesis is denoted by HO. So first we agree, okay, and the alternate hypothesis. What is the alternate hypothesis? Step 2. The alternate hypothesis is the opposite of null hypothesis. It is the opposite of null hypothesis. It is assumed valid when the null hypothesis is rejected after testing. So we do conduct some tests to validate whether the null hypothesis is correct or the alternate hypothesis is correct or not. Okay. In the case of the engineer that testing the carbon monoxide, the alternate hypothesis would be H1. The level of carbon monoxide generated by is not twice as great as the legally required amount. So it can be equal to, not equal to. Very simple it is. Null hypothesis, alternate hypothesis. Alternate hypothesis is not equal to. I went to the movie was good. That is null hypothesis. Alternate hypothesis, I went to the movie was not good. That is the alternate hypothesis. But you have to test whether what I am telling is correct or not, whether the movie was good or not. You have to test it. Is this okay? Alternate hypothesis, null hypothesis?
Yes, sir.
Okay. Now step 3. Step 3 here. Testing the hypothesis. The objective of the test is to generate a sample test statistic that can be used to reject or fail the null hypothesis. The test statistic derived from Z formula, if the samples are greater than 30, Z is equal to X bar minus mu divided by sigma into standard into square root of N. Okay. And here is an example. We'll go to this. A machine used to average a production rate of 245 units per hour before it went for repair. After it came back from repair over a period of 25 hours, it produced an average of 249 units with a standard deviation of 8. Determine if there is a statistically significant difference between the machine's productivity before and after repair at a confidence level of 95%. So this is the problem. Now you understand this example? Kindly read it, please. Have you received this document which I sent to you?
Yes, sir.
Yes.
Yeah. This example will make you understand how to do null hypothesis test and alternate hypothesis test. Since the sample is smaller, we have known the t-test which is given there in the analysis phase. Since the sample is smaller than 30, we will use the t-test. The null hypothesis is what? HO. It is denoted by HO. The productivity before repair equal to productivity after repair. It will be equal to. But the alternate hypothesis is what? Should be opposite. The productivity before repair not equal to productivity after repair. And what is the number of N is equal to 25, standard deviation, S equal to 8, X bar equal to 249, X bar is the average, and mu is equal to 245. We apply the formula and then calculate it and use the calculation to find out whether it is correct or not, whether the null hypothesis should be rejected or whether the alternate hypothesis should be rejected. This forms the crux of the analyze phase. Okay, this formula and the T table and everything will be explained in the green belt, the black belt program, because it's beyond the scope of the, but I took it because you have to understand what is a null hypothesis and what is the alternate hypothesis. And secondly, first is parametric hypothesis testing, and the second one is non-parametric hypothesis testing. What is non-parametric hypothesis testing? Non-parametric hypothesis testing nothing but for data which cannot be measured on a measurement scale. So hypothesis testing is of two types, parametric testing and non-parametric testing. Please note it down. Hypothesis testing is of two types, parametric testing and non-parametric testing. Non-parametric testing is not for continuous data, it is for discrete. That is data which cannot be measured. That is for non-parametric. And for non-parametric test, we use the chi-square test. Chi-square test is used for non-parametric testing. From the examination point of view, I have given you some pointers which you will be able to understand from the question paper that which test has to be used. So chi-square test is used in non-parametric hypothesis testing. Okay, is everybody clear?
Yes, sir.
Okay, so now we understood what is hypothesis. Hypothesis is nothing but an assumption. Either it can be true or it can be false. I made an assumption that the movie was good. I made an alternate hypothesis that the movie was not good. But I have to prove it using a formula. That formula will be taught to you in the black belt program. Okay, don't need to break your head using knowing that formula. We'll take a break of 10 minutes and return back. And as like yesterday at 1 o'clock, we'll 1 or 12:45 break for lunch and return back at 1:45. And we'll practice after lunch on the various tools, that is Sigma Excel and Minitab, to get a fair amount of idea how to use Minitab, how to use Sigma Excel, all this thing. Okay. So relax for 10 minutes and go through the Minitab. Minitab distributor is a company called QSutra. I'll type it here. If you are able to extend your Minitab, it's much QSutra. It's at Koramangala, Bangalore, head office of India. You can Google it and get the number. So if you want to extend your 30 days period, you can get it extended further. First, you have to clear the examination. So they will ask for your certification, whether you are certified or not. Unless you are not certified, they will not extend your license. Okay, so certification is important. Oh, okay, we'll come back after 10 minutes. Okay, Tina?
Yes, sir.
Okay.
I'm here too, sir.
Yeah, what we learned is, we'll do a quick recap. What we learned is what? We have learned the basic terms of statistics, basic and slightly advanced. One is mean, mode, median, range, standard deviation. Standard deviation is calculated by the formula. It is noted by the symbol sigma. Sigma is equal to square root of sum of x minus x bar the whole square divided by n, that is n is the number of observations. Then we have learned the statistical term Poisson distribution, normal distribution and which one? The other distribution, exponential distribution and binomial distribution. These are the statistical terms which are used. Okay. So now what we do is we'll go to the other part that is very useful is p-value. I want to explain to you what is p-value because while interpreting graph, you require to understand what is p-value. P-value is a very important. It is always shown in the graph. Whenever we take a graph, it is shown as a p-value. The p-value is shown in the graph when you take a graph of Minitab. P-value, say for example, you know about pi in mathematics. Pi is equal to 3.14, which is a constant. Okay, pi is equal to 3.14. We use that pi for various other calculations. Pi r square, area is equal to pi r square. We use the value pi there as 3.14 and calculate the pi value as the area of the pi r, area of the circle. Okay, so p value is also a statistical constant which is at the value alpha is equal to 0.05. Now what is the p value? P value is at 0.05. Like in mathematics, pi is equal to 3.14, p value is equal to 0.05. You have to remember just this much. P value is equal to 0.05. And if the p value is greater and less than, we have to draw a interpretation regarding if it is less than 0.05 and if it is greater than 0.05, we have to draw a particular interpretation. I'll tell you how to draw the interpretation. How to interpret if p value is less than 0.05 and p value is greater than 0.05. P value is a constant which is at equal to 0.05. What is normalizing data? Very important. Please note it down. Normalizing data. Non-normal data. Outliers can cause your data to become skewed. The mean is especially sensitive to outliers. Try removing any extreme high or low values. Removing any extreme high or low values and testing your data again. See, what is skewed? Skewed, yesterday I showed you, I introduced some data, 11, 12, 11, 12, and then suddenly I introduced one number called 40. That is a skewed data. So you have to remove that data from then only the data becomes normal. Otherwise the data is not normal, it's called to be a skewed data. When data being analyzed are not normal and the tools required for analyze require the normality, then one option will be to normalize them. See, there are certain tools like, say for example, t-test will require data to be normal. If your data is not normal, some tests are required the data to be normal. If the data is not normal, then that test cannot be carried out. So, how will you make the data normal? You have say 100 and 2000 of data. How can you make all that data normal? It's humanly impossible. Then you have to use Minitab. Please note down, to make the data normal, you have to use Johnson transformation. Johnson transformation. To make the data normal, you have to use Johnson transformation. I'll show you in Minitab how to make the data normal. Example, see here I have highlighted. From the menu bar of Minitab, click on Stat. Just do this exercise. Just do this exercise along with me. From menu bar of Minitab, I'll take you to Minitab. My Minitab is expiring in another 12 days. Okay. From the menu bar, here I have written what? From the menu bar of Minitab, click on Stat, then on Quality Tools, and from the drop-down list, select Johnson Transformation. Click on new. New Minitab project. Okay. Okay, so a new screen comes. So what we do is enter some values here. Non-normal. I use the same value 11, 11.2, 11.3, 11.4, 11.9. Then I enter a outlier or a skewed data. I enter 50. Then I enter 12. Okay. What is this, Hina? This is a non-normal data. Are you right? Am I right? This is a non-normal data. Are you following, Hina?
Yes, sir.
Oh, this is a non-normal data. Why? Because there is a value called 50 here. 50 is there. 50. Now what you do is go on Stat, click on Quality Tools, take Johnson transformation. Johnson transformation. Click on that. C1 you select. C1 you select. That is non-normal data. And then it asks for store transform data in single column. Yes, you give the column called C2. Store transform data in single column. You give the transform data single column C2. So your transform data will stored here. Okay, in C2 column. And then click on OK. You get the graph. See, there is an outlier here, outlier. And what is the p-value? P-value less than, I'll enlarge this. See, in the C2 column, I have not entered anything in the C2 column, but it has automatically populated the C2 column with -1, -0.8274, -0.40638. All this is a normal data. So now you can carry on your test with this normal data. So if somebody tells you what I'm giving you data, some data is not normal, some data contains skewed data or outliers. How will you carry out the test? Then you say, I do Johnson transformation. Johnson transformation is nothing but to convert the non-normal data into normal data. How it is done? It is done automatically with the use of the Minitab tool. And what is this is graph interpret? See p-value, first the normal data p-value less than 0.05. Okay. And probability plot for transform data is what? It is within the upper specification limit and the lower specification limit. Yes, it is not crossing here, but here it is crossing here. See here, here it is crossing the upper specification limit and the lower specification. What is the p-value here? P-value here is 0.858. That is, it is greater than 0.005. That is, it is a normal data.
Sir, you did not enter the upper specification limit or lower specification limit in the earlier column. So how did it get that?
Which one? In the column. That is automatically taken by the statistical tool. That is automatically. I don't have to enter anywhere in the column. It creates a range for itself to draw the graph. See, upper specification limit and lower specification limit. Here we don't have to enter. It is automatically created by the graphical software. Okay. And here there is no mention of upper specification limit. Thus the graph is showing in this format only. Okay. So here this is going outside and here it is within the limits. So this is transform data and the p-value is equal to 0.858, which is greater than 0.005. So it is a normal data. So anything greater than the p-value is supposed to be a normal data. And the transform data is where? The transform data is stored in the where you got the transform. Have you done the exercise with me? Ashish? Have
The
you done
transform data is in the second column, no sir. I haven't done it exactly.
same column? Have you not seen the screen?
Yeah, I've been seeing the screen, sir.
It is in C2 column. It is not in C1. The non-normal data is entered in the C1 column.
Yeah, and the
and
transformed data is delivered in the C2 column.
Yes, that is what is Johnson transformation. It's a very important thing. It will be asked in the examination. Okay. Hina, have you done this exercise?
Yes, sir.
See,
So
how to do it is very simple and straightforward. You have to first enter the non-normal data with an outlier or a skewed data in column number 1. And in the select, go to Stat, Quality Tools, select Johnson transformation, and then select the column where you want the normal data to come. And the column will be populated with the normal data and the graph will be shown.
sir, does this mean that it is changing the value of the outliers to fit it within the specification limits?
Yes, outliers are not to allowed. No, outliers create problem. They create variation.
Yes.
Are you clear on this? Outlier is a skewed data. See, I introduced data 11.1, 11.2, 11.3, 12, and suddenly I put 50. That's an outlier. Okay. So we have to first transform this into normal. And how to do that? We have to use Johnson transformation. Okay. How to do that? We have to use Johnson transformation. From the examination point of view, sorry, excuse me. From the examination point of view, you will be asked what is Johnson transformation or what is Box-Cox transformation. It's very simple. It's a process of converting a non-normal data into normal data. Is everybody clear on this? Because this is very important because this will be asked in the exam. Is everybody clear on this? Please type in your answer or just tell.
Yes, sir.
Okay.
Now, clear about Johnson's transformation.
Huh?
Clear about Johnson's transformation.
Yeah, you have heard about it. No, that's it. Okay, now you have heard about this also, ANOVA. ANOVA will be asked in the exam. What is ANOVA? What is ANOVA is, if for instance 3 sample means A, B and C are compared using the t-test is cumbersome. For this we can use analysis of variance, ANOVA, instead of multiple t-tests. So we should not use t-test for samples more than 3. How to demonstrate that? I'll show you. Johnson transformation will be asked in the exam actually. It is it's a very important test to convert the non-normal data into normal. See, t-test is using a formula actually, and that is beyond the scope of the green belt. It will be discussed in your black belt session. What is a t-test? ANOVA also is using a formula, and when there are more than three sets of columns, so for example, in a column it contains more than three sets of data, you can use ANOVA. ANOVA is a test only. It's used in analyze phase. ANOVA is used in analyze phase. So for example here, like this, if we have this data like this, octane, compression, revolutions per minute, HP, or more than one column, that is C1, C2, C3 and C4, there are four columns involved. You can use ANOVA instead of a t-test. Okay, you can use ANOVA. There is ANOVA option is there. You can check it in your free tab. You can click on ANOVA and click on one way. Don't use the other parts of it. Only click on one way. ANOVA, click one way. One way ANOVA is better. Okay, now what we have is we are finished with ANOVA. You do this exercise on your own. Okay. How to problem of two-way ANOVA. Consider an experiment on aluminum castings. Customer requires hardness to be controlled. Hardness is an important quality characteristic, CTQ. We therefore want to evaluate the effect of two factors on hardness. Why? The two potential contributors are percentage of copper and magnesium. We have controlled copper percentage at 3.5 and magnesium at 12 at 1.2 and 1.8. Percentage data is available in the file hardness. So open the XLS file ANOVA hardness and the Minitab window opens. See here, I'll tell you. See here, I opened a file called magnesium copper hardness. What will be the independent variable and the dependent variable in this magnesium copper hardness? Which column will be the dependent variable and which column will be the independent variable? See, the presence of magnesium and copper causes hardness. So hardness will be the dependent variable and magnesium and copper will be the independent variables. So the presence of magnesium and copper has an impact on the hardness of the casting. Are everybody, this basic thing, everybody clear? Enough?
Yes, sir.
Yeah. See what happens, the hardness of the casting is affected by the amount of magnesium and copper. So the C1 and C2 columns are the independent variables and C3, that is hardness, is a dependent variable. Why? Because hardness depends on the amount of magnesium and copper in the steel casting. Okay. So what we do is, how to do it? I have given it in there. ANOVA and select two-way. Okay. Go to stack, take ANOVA and click on two-way. What do you do? Response variable, row factor, column factor. What will be the response variable? You have to select something here. What will be the response variable? Now you will start learning all this, yeah?
Hardness.
Hardness, yeah, exactly. Hardness, select. What will be the row factor? Copper. Select. Magnesium, column factor. And then click on OK. You immediately get everything. P value also you have got. You have to just focus on this P value. From that info, what do you infer? So p-value is greater than 0.05 here. Greater than 0. Each mean square value represents variance due to source mentioned in the row. We can conclude that the magnesium and interaction between magnesium and copper have significant effect on the hardness of the aluminum casting. Why? Because there is a variance in the mean square. One is this 1.125 and the other one is 21.125. So there is a lot of variance there in the mean square, MS. From that, we can infer that there is a significant effect on the hardness of aluminum casting because of the presence of magnesium and copper. Okay. Now we go to the slides of Gray Campus. So in analysis phase, we have covered this hypothesis testing. Okay. So you need not worry about this. We have covered this. You can refer it in your after the session is over. And then what we have, the second one also is analysis. Hypothesis testing with normal data. This also we have covered what is normal and what is not normal data. This just contains 8 slides. The total number of slides is what it contains is just 8. Okay, what we have covered is board. And there is one important formula which I want to share with you. This is one formula which you can keep it or write it down in your notebook. Sample size for continuous data can be calculated by n is equal to the whole of 1.96 sigma divided by delta the whole square. How can you calculate the sample size? N is equal to, it's all about formulas, okay. N is equal to the whole of 1.96 sigma divided by delta the whole square. This can be asked in the examination, how to calculate the sample size. They will not give you a question, but they will ask you the formula. I just filtered out certain things which can be used in the examination. Ina, I am clear?
Yes, sir.
Okay, so sample size. Now you understood, no, what is the meaning of ANOVA. If there are more than one sets of data and then there is a correlation between the data, that is, the two data are affecting the dependent variable, you can use the test of ANOVA test. You can use ANOVA and it is used in the analyzed phase. Okay. Sample size for continuous data can be calculated by n is equal to the whole of 1 minus 1.96 sigma divided by delta the whole square. Delta is the precision of the level of uncertainty in your estimate that you are willing to estimate. Asset. We have covered sample size for discrete data. Slightly different. N is equal to the whole of 1.96 divided by delta the whole square P into 1 minus P. P is the proportion defective that we are estimating. We have to estimate P. So it's a guess. It's a guesswork. Okay. The guesswork. Discrete data. And the other one is for, the other formula which is given above is for continuous data. That is data which can be measured on a measurement scale. And for discrete data, this is the formula. These two formulas are important and the formula of standard deviation. For a green belt, these three formulas are more than enough for a green belt. This may be asked in the exam. Sample size for discrete data. Discrete can be calculated. Okay. So in analysis phase, we have covered what all things we have covered. We have covered parametric hypothesis testing, non-parametric hypothesis testing. We have covered ANOVA. We have covered ANOVA, that is two-way ANOVA. We have demonstrated on Minitab. Then we have explained what is p-value. P-value is a constant 0.05 against which various assumptions can be made or various results can be interpreted. We have learned about Johnson transformation, how to convert the non-normal data into normal data. That is called Johnson transformation. And we have learned about chi-square. And we have learned about null hypothesis, alternate hypothesis. Any questions till now? Hina, any questions? You see, analysis phase in your company, that is Tata Telecommunications. What I suggest is, what is your designation, Hina?
Sir, I am with Amazon, sir.
Oh, you're for, then somebody told me Tata Communications.
Yes, sir. Alka, sir.
Alka, the female voice. Sorry, I got mixed up with the two female voices. Yeah. See, in Amazon, Hina, in Amazon, what is your designation?
Sir, I am a project manager with Amazon, sir.
Oh, you're the project manager with Amazon. So, what are the problems? So, we'll have a slightly interactive session. What are the problems you are facing and so what is the main objective behind taking the green belt and black belt course?
Sir, objective was not very much company specific, but I am thinking of kind of identifying some sort of a opportunity where I can implement this. So I am presently with the customer service division. I am managing projects for the customer service division. So there is a lot of opportunity for implementing the process improvement kind of initiatives, but I haven't really thought about it. So the ultimate output of the customer service division is the contacts, or rather the calls that come to Amazon. So there we also keep on running a lot of internal process improvement initiatives, but I'm not sure if we go via this Six Sigma framework or not, because it's...
I'll guide you 1 minute. I'll guide you 1 minute. As Six Sigma, as anybody there knows Six Sigma, or anybody is a black belt certified person there in your company?
Yeah, there might be many, but I haven't really heard that someone is putting in practice the Six Sigma framework for a particular project. So there are many Six Sigmas in our company, but I don't. Projects are driven by this methodology or not.
The basic thing is, if you don't put it into practice, what is the use of getting certified? You have to make it certified. You have to get into practice. So what do you think is the problem you are facing in your day-to-day activities?
So there are many. So ultimate goal for the customer service division is to reduce the number of calls that come to Amazon. So that is to make the systems sufficient enough so that the customers can go to the website and check whatever is required for a particular order. So that is the ultimate goal, but yes, that's a very broad goal, and to pick up some project, I suppose the goal should be quite narrow.
No, you have to do a work breakdown structure and put it on a Ishikawa diagram or a fishbone diagram and note down the problem statement. That is to reduce the number of calls coming to your office, right?
Right.
So what is your project would be? I will tell you what is your project would be. Your project would be like this. You gather the voice of the customer, and if there are employees within your organization who are complaining, you gather, they are also customers only, no? They are internal customers. They are not external customers. So you gather the details and collect it on put it on a Ishikawa fishbone diagram. But you have to interact and interview each person. What each person is facing a problem. You cannot just put it in a very broad manner, because if it goes in a broad manner, it will not work for you. So, are you PMP certified?
No, sir.
No, you are not PMP certified. Okay, but you'll be able to do the work breakdown structure and break the problem into 5 smaller parts and put it on a wishbone diagram and then analyze it and then take necessary action with your superiors brainstorming. If there are any black belts in your organization, you try to get in touch with them and also work randomly along with them. I don't know whether your department you have any black belts or not.
Yes, sir.
Okay, so that would be the ideal way to do it. So that's it. We finished the analyze phase. Now remaining is improve and control. Improve and control is remaining. We learned Minitab, we learned Sigma Excel, and there is one more software called Quality Companion, which is easy to use. I'll just show you before we break for lunch. See, Quality Companion comes with this kind of icon.